Hi everyone, welcome to another video tutorial, and today's topic is going to be about object-oriented programming in Python, and this is going to be the second video in this topic. And in today's video we're going to be discussing about different types of relationships in Python. So there's two different types. One of them is has a relationship. The other one is a relationship. And we're going to be talking about something called polymorphism. And finally, we're going to be discussing about abstract classes. So let's quickly get started with has a relationship. So what is a has a relationship? So it can be like a person has a job, a person can have a home, a person can, or a dog has a bone, something like that. So we're gonna be showing this type of relationship and how it can be coded. And the example I'm going to be showing is person and a job. So let's quickly code a job in a class. Let's create the init method. Some properties of a job can be a title, employer, and so on. Self.employer equals employer. Let's code a person, class person. Let's have the init method for a person. A person can have a name, age, and let's have a job. So this right here, job equals none, is a optional parameter. So if we include this third parameter, job, it can be so this job variable will take in this that job object. If not, it'll be initialized to none. I will show you that in a second. So self.name equals name, self.age equals age, self.job equals job. So let's try to print. Let's create a person object. Let's call them person1. Let's give the properties name, age. For the first example, let me just do their name is VP. Their age, let's say, is 40. And finally, let's not give them a job yet. Now let's try printing their name. Sorry, I didn't name the constructor properly. Let's try that again. So we have here their name, and if we try to print out their job, it's gonna be printing out none, because the optional the optional parameter here, we have initialized it to none. Now let's create a job object, give it the title. So a job object takes the title and the employer. So we can have here software engineer or dev. Then we can give the employer name subatomic labs, right? And let's create the person object after creating the job object. And finally, let's give them the job as such. Now if we print this out, we can see here the name of the person is printed out, and we have the object which is printed out as well. So we can try to print out the title of the job. You can see here software dev is printed out. We can also try to print out the employer. Job has no attribute employer. Did you mean employer? Oh, I kind of named it wrong here. Employer. We can see here the employer is printed out now as well. So this is how we can sort of code has a relationship. So the person class has a job object. And we can also create many other persons with different types of jobs. The next relationship that we're going to be looking at is called is a relationship. And some example is like a person is a human being. Another one is a dog is an animal. A cat is an animal. A car is a vehicle. A truck is a vehicle. So there's some definitions that we should learn here. So a person is a human. A person in this case is called a subclass, and a human is called a superclass. And we can also say a person is a child class, a human is a parent class, and the child inherits from the parent. Or an animal, a dog inherits from the animal. Let's quickly show the is a relationship in Python using class human and class person. So a person is a human. Let's code the human class first. Let's have the constructor as such. A human being can have a name, age, gender, or let's just say a human has a species, because there are different types of human beings, Neanderthals, Homo sapiens, and so on. So self.species equals species. Let's create the person class now, and a person is a human, and the way we inherit from the superclass is that we include the parent class in these brackets. So a person inherits from a human. So the person will be the subclass, human will be the superclass. Let's create the constructor for class person. Person has a name, self.name. So we initialize the property name. And to set a variable in the superclass in human, we do super dot init and we give it the species. And let's assume a person is a Homo sapien. We could do Homo sapiens. Sorry, Homo sapien. And okay, let's try creating a person. Person1 equals person, and let's call them VP. Now, what we already know is that we can print out the name property of a person. And we can see here VP is printed out. But with the person class inheriting from human, we can also print out the species variable from the human class. And this should print out Homo sapien, because this super is referencing the human class, and we're calling the constructor of the superclass human and giving it the species name Homo sapien. We can also do something called polymorphism, and this is the ability of objects of different types to be treated the same way. And in Python, the way we do this is we can have two classes having the same name, method name. We can have here def get name, and here we can print out the species name, and here let's do get name and see. Let's just print out the class name. Just say human here. Human def get name print person. Let's create a human, a separate human. Let's call it human1. Let's call it Neanderthals. So here, what we can do, sorry, this should be human. We can print out human1.getName, And we can also do person one. And these two, they're gonna print out person, and then none. Why is it printing out none here? Hmm. Oh, I think it's because the get names function, they return none, and we don't want to be printing that out. Let's just call get name as such, and we should be seeing human and then person. The human here is not a capital. This is not specific to is a relationships, but this is a topic of polymorphism. Something that is specific to is a relationship can be called as method overriding, and it is pretty much when a subclass can override a method of the superclass. Let me show you an example of that one. So let's say we have get name in the human superclass and not in the person class. And in the get name, let's print out self dot the species name. So in here we have a person one person object with the name VP, and it inherits the species variable from the superclass. Let's do person one dot get name. Here, what it should be doing is calling the get name method in the superclass. Homo sapien is what's being printed out. For method overriding to take place, we also define a get name function in the person class, and what we do here is print out the name of the person. And now when we print this out, what we see here is the name of the person is being printed out instead of the species name in the human superclass. So there you have it. That's the is a relationship, a person is a human. And finally, I want to show an example of abstract methods, and or an abstract class, and this is a superclass that can be defined as an abstract class. And this super abstract class, it defines methods that should be or are required by the subclass. Let's show this example with species and human. So a human is a species. So let's show this. So to code abstract classes, we should import certain libraries from ABC, import ABC, and we should also import abstract methods. So to define an abstract class, what we should do is the species, the abstract class should inherit from ABC, which indicates that species is a abstract class. Let's give it an init. Species soft dot species equals species. And let's define an abstract method die, and let's put in pass for now. Abstract method. And the way we denote that die is an abstract method is we put a at abstract method above the function definition. Now let's create an abstract, a class which inherits from the abstract class. Let's call it a person. Excuse me. And let's inherit from species. Def. Let's create a constructor. And let's give it a name. Self.name equals name. And since, sorry, this should be class person. Def. And since person is inheriting from the abstract class species, we should be also defining the method die. And let's just say dead. So if we press play, we can see here that nothing's happening because we didn't create an object yet. Let's create a person class with the name VP again. And let's print out person one dot die. Sorry, let's not print this out. It says I'm dead. The problem is, and the question here would be, what's the difference? And let's see, there is no die method. And in this case, if we initialize a person object, if we press play, we can see the error can't instantiate abstract class person with abstract method die. We get the error, and this is because the person class is not defining its own die method. So there you have it. In this video we covered has a relationship, is a relationship, polymorphism, and finally we ended off with abstract classes. So if this video helped in any way or form, please like the video, subscribe to the video, and because in the next video I'll be covering more object-oriented topics such as encapsulation, abstraction, and also comparisons with type and is instance. And yeah, thanks for watching.